Hey guys, Mrs. Sands here. So today we're on lesson 10. Lesson 10 is actually just more practice with functions. So together we did two handouts. Lesson 8, which was the introduction to functions, that each input can only have one output. And then lesson 9, a handout that really introduced us to using function notation. Remember, we had said that sometimes function notation can be a bit confusing, but once you get used to it, it's actually a nice way of dealing with functions and knowing what the input is and figuring out what the output is. So if you could just write down the objective, that we will continue practicing with functions. And today we're actually going to learn how to use our graphing calculator. Maybe I shouldn't say learn, maybe I should say refresh your memory about how we can enter things into our calculator to maybe help us answer some questions. And I actually want to go over your homework with you here. I have put it into your Google Classroom so that you could see what the notes were from lesson 9 along with the homework, but I'm going to talk about it right here. So just as a reminder, we learned about this function notation here. We call this, remember, f of x, where x represents your input. And then after I plug in whatever value is there into x, I get my output. So for part A, they're asking me to plug in a 4. So when I do 2 times 4, add on 1, I get 9. So that means that f of 4 is equal to 9. So take a look at the answers to B, C, and D. And when I see you next, I can answer any questions that you have, but it's pure substitution. If we look at number 2, again, we're talking about a function. This time they're calling it g. Any number that they put in here is my input. Therefore, I'm going to put it in place of x. So if I look at letter A, I have to figure out what g of 9 is. I put a 9 in place of the x. And when I follow the order of operations, 9 minus 5 is 4. And then 4 divided by 2 is 2. So that's how come f of 9 is equal to 2. And then you could check your answers for B, C, and D. Again, I'll answer any questions when I see you next. If we look at number 3, we're back to a function that they're calling f. It's defined differently, though, than as number 1. They're saying f of x is defined as x squared minus 4. So just be careful about squaring. Remember, we did that in Unit 1 of our polynomials. Anytime you substitute a number in place of x when it has an exponent, please make sure you put it in parentheses, especially when we're dealing with our negative numbers. So you could see that I had to find out what f of 3 was. So I substituted in a 3 in place of x. And again, notice I put it in parentheses. So I'm doing 3 squared, which is 9, and then take away 4, and that's how I get an answer of 5. I want to talk about b because now I'm substituting in a negative 4. Again, these parentheses are necessary. Negative 4 is being squared. Negative 4 times negative 4 is a positive 16, and then 16 take away 4 is 12. And you can take a look at the answers for C and D. Number 4, they are defining function f as being x divided by 2 and then take away 6. And they're asking us which one is f of 10. So you just plug a 10 in, turns out to be choice 1. I like number 5. You will see things like that on your Regents exam where they're comparing two functions. So they define f of x for us and they define g of x for us, and they're asking which statement is true. So I actually went through each one to find out what was true. So I found out that f of 0 was a negative 3. I kind of did it in my head. 2 times 0 is 0, and then take away 3 gives me a negative 3. And then I found g of 0, again, kind of did it in my head, because 3 over 2 times 0 is just a 0. Add on 1, the answer is 1. And if I was picking choice 1, it would say that negative 3 is greater than 1, which is false. So I know my answer is not choice 1. So I did that for each one. I substituted in a 2 for function f and g, and 1 does not equal 4, so it's not choice 2. If we look at choice 4, I substituted in a 4 for both function f and g, and it would say that 7 is less than 5, which is false. So finally, we look at choice 3. When you substitute in an 8, you get 13 for both of them, so that's why it's choice 3. Now we're taking a look at a graph. Remember, we talked about that inputs and outputs are actually points, right? If an input is x and an output is y, I should be able to plot it on the coordinate plane. So they gave us a graph of a function. They're asking me what is g of negative 2. Really, they're asking me to find a point on the graph whose x value is negative 2. And then I just have to state the y value. So that's what I have to do, like for part A, the first part, g of negative 2. Find a point on the graph whose x value is negative 2. So I go to negative 2. I go to see what point corresponds to it on the graph, and I see that the y value for that point is a negative 3, right? Because this point is negative 2, negative 3. So therefore, g of negative 2 is equal to negative 3. I love finding values when they give me a graph. I prefer looking at a graph instead of plugging it into a rule that's given to me. I just find it quicker. So if I want to find g of 0, I find a point on the graph whose x value is 0. That would be this point right here. It's the point 0, negative 3. I just realized I made a mistake someplace. This y value is a negative 3. I'm going to go back to this. 1, 2, 3, 4. This y value is a negative 4. My answer key was wrong. Negative 4. You might have been thinking that, maybe even screaming it out loud while I was doing it. No, Mrs. Dans, the y value is a negative 4. Sorry, from this end, I couldn't hear you. So back to the first one. G of negative 2 is definitely negative 4 because that is the point 2, negative 4. And then G of 0 is negative 3 because this is definitely the point 0, negative 3. So I hope that's all cleared up. Sorry for the mistake that I made. How about G of 3? 1, 2, 3. I go up 1, 2, 3, 4. I agree with my answer this time. It's 3 comma 4. So G of 3 is equal to 4. What about G of 7? 1, 2, 3, 4, 5, 6, 7 is right here on the x-axis. So it's the point 7, 0. So I agree. G of 7 is 0. So what values of x solve the equation when g of x is equal to 0? Really what they're asking us to do is to find the x values whose y value is 0. That's what I uh, wrote right here. Find x values whose y value is 0. When they give me this answer, they're giving me an output. An output is a y value. So I used this aqua color line here. I drew a line along the x-axis because that's when y is 0. And I circled all the points in that aqua color. I don't have that exact color anymore, but this point right here, this point right here, this point right here, and this point right here. So it would be 1, 2, 3 when x is negative 3, or when x is 1, or when x is 5, or when x is 7. Okay, those are the 4 points whose y value is 0. So just be careful with how they're presenting a function to you. I'm going back up to part A for a second, looking right here at g of 7. Remember, when they put a number in parentheses, that's my input. The result over here is my output. So they gave me an input here. I had to find the output. In part B, it's the reverse. Look at, I have nothing for an input. They gave me an x. They told me the output was 0. So I had to find all x's whose output was 0. If we look at part C, how many values of x solve the equation when g of x equals 2? So now they're telling me find the x values whose y values are 0. So I drew a horizontal line where the y was 0, and I circled them. There's 1, 2, 3, 4. There are 4 values whose 4 values of x whose y value is 2. I can't give you the exact answer for those values because they're not integer values. They're like in between the integers. Therefore, they're rational numbers. Actually, could even be irrational. They're real numbers, maybe I should say. But there's 4 of them. Number 6. So they give me a rule right here, right? H of t is equal to 100 minus 16t squared. So this is kind of like a science experiment. They're dropping a ball from a height of 100 feet. So that's how come this rule makes sense. We're starting at 100 feet and then it's losing height. It's losing 16 for every second squared, right? So just plug in a 0 for this first one and you wind up getting 100. That really makes complete sense. Remember, the input in this case is your time in seconds, and the output is your height in feet. So at 0 seconds, it means I haven't dropped the ball yet. So the ball started at 100 feet high. No time has passed, so it's 100 feet high. So that really does make complete sense. In part B, they're asking us to calculate h of 2. They're asking us to figure out what is the height of the ball after 2 seconds have passed. So plug in a 2, be careful with your calculations, you get 36 feet. What does that really mean? It means that the ball is 36 feet high after 2 seconds has passed. Does the ball hit the ground? Absolutely not. It's 36 feet high still. Number 7. They give me that the input is -4 and that the output is 8. I can write that as an ordered pair as -4, 8. And they want to know why it is a point on the graph. Well, an input is an x value, an output is a y value. So -4, 8 would be a point on the graph. That's all. It's just making sure you understand your function notation. So I'm hoping I could actually go through today's lesson rather quickly now since it is the same stuff. So consider the linear function where f of x equals 1/2 x plus 2 and evaluate showing your work. Why don't you do that right now? So at any time during this lesson, you may have to pause, especially when we take out those graphing calculators. But I thought part A was rather quick. So, oh, I see I made a mistake already. I didn't plug in a -6. So this is not a 5. -3 plus 2 is a -1. The rest I agree with myself on. So f of -6 is -2, f of 0 is 2, and f of 8 is 6. Now it says confirm your answers using your graphing calculator. So get out those graphing calculators. And again, if you need to pause because I'm going too fast, please make sure you do. But to put this into our graphing calculator, remember we said that f of x is actually y dressed up nice and fancy. So in our y equals button, clear out anything that's there if there's something there. We'll type in 1/2 x plus 2. Remember alpha y equals enter, get you a fraction, help your neighbors out if they need it. Sorry, I had a glitch there for a second. So I got in my 1/2. Right here is your X button, and then plus 2. And then remember, above the graph button, it says table. To see anything written above a button, that's your second function button. So I'll hit second graph, which really gets me to table. And I'll scroll through to -6 to make sure I did that right. -6 is a -1. And then at 0, it's a 2. And I'll scroll down to 8. And I see at 8, it's a 6. So I agree with my answers. In part B, it asks us to determine a value of x for which f of x equals 11. So they're telling me that the output is 11. Remember, your output is in this y column. Let's keep on scrolling until we see an 11. I see an 11 when x is 18. So determine what value of x? Well, it's when x equals 18. You can prove this algebraically if you need to. I can write an equation that says the output of 18 equals 1/2 x plus 2. And then I want to solve this. So let's subtract 2 from both sides first. So 16 equals 1/2 x. And now let's multiply both sides by the reciprocal. So I'll multiply by 2 over 1. So therefore, x equals, Miss Stan's made a mistake again. The output is 11. I don't know what's wrong with me today. So I subtract away 2 from 11. That's a 9. 9 times 2 is 18. Jeez. So 18 matches what I thought it was. The input of 18 gives me an output of 11. I am sorry again. I put the input where the output was supposed to be. Okay. That says confirm your answer using a graphing calculator. We did that first, so that's how come I knew I was wrong to begin with, and I caught my answer. Now it says use the table to fill out the following table and graph the function. So if we open up our graphing calculator again, we will look when x is -6, it's a -1. When x is -4, it's a 0. When x is -2, it's a 1. When x is 0, it's a 2. When x is 4, it's 4. And when x is 6, it's 5. And now we can plot these points. I'm happy that my points landed in a straight line because this is a linear function. It's in the form of y equals mx plus b. Honestly, I would not have graphed this using a graphing calculator because it's just too easy to start at your y-intercept of 2, which is right here, and then use the slope of 1/2, go up 1, right 2. There's actually a point right here, even though it wasn't in my table. Up 1, right 2, up 1, right 2. Of course, I could go in the other direction. But the goal of today's lesson was to remind you how to use your graphing calculator, not to remind you how to graph. But now at least you know we can graph using our graphing calculator. What's nice with function notation is I usually label this with just the function name. I just write f of x because now I'm going to graph function g. Function g is defined as 5 minus x. And I am going to just do this using the slope and y-intercept first. My y-intercept is the 5, right? If I use the commutative property, I get g of x equals -x plus 5. So my slope is actually -1 over 1, while my y-intercept is a 5. So if I were to graph this, I would start at 5, and I will go down one, right one. Remember, we like our lines extended all the way to the edges of the graph paper. It's hard for me to draw a straight line with the tool that I'm using on the calculator, so I'm sorry for this squiggly line. And I can name this g of x. Anytime you have more than one graph on a set of axes, they must be labeled. If they're not labeled, you will lose points. And again, a nice thing about function notation, just name it its function name. You don't have to write out the whole thing. It's asking us to find the point of intersection. It's right here. The point of intersection is at 2, 3. And it asks us to look at our table for this. So let's go back to our graphing calculator. Let's hit the y equals button and keep your y1 in there. Move down to y2 now. And in y2, let's put in this 5 minus x. And let's go to our table, which is second graph. And I think they intersect at the point 2, 3. If I look right here, I can see that an input of 2 has an output of 3 on the first graph and an output of 3 on the second graph. So they really do share that point, which means they really do intersect at that point. If you felt like looking at the graph on the screen, I want you to always get used to going to this, excuse me, this zoom button. Hit zoom. And then since this is a function, we like to graph in standard mode. So move down to 6. And that's f of x. That one's g of x. And I could see where they intersect. Now, the quality of the graphing is not superb on this graphing calculator. You actually see it better when you do it by hand, but at least I can confirm that I must have done things correctly because they look pretty close to each other. So on the next page, it's just more practice of function notation like what you did for homework. That's why I wanted to go over your homework so thoroughly. I don't feel like I really have to do every question here. There's a few that I'll pick out. So let's start with, I guess, D. And let's plug in a 7 in place of X. Don't forget to put it in parentheses. Now, you can do this calculation on your own. The order of operations say you have to square first, so you'd have to do 7 squared, which is 49, and then multiply it by 2, and then subtract away 4 times 7, which is 28, and then subtract away 3. But guess what? You've got this nice tool here. You can just go to your home screen. So your home screen is that main screen. Sometimes if you just hit clear, you get back to the home screen. Other times it feels like you're stuck. You have to use like the quit button here, so you could hit second mode, and it gets you back to this home screen if your calculator feels stuck. But anyway, I'm going to type in 2 and then my parentheses, 7, close parentheses. Right here is my squaring button. Do you see where I'm pointing? 1, 2, 3, 4, fifth one down. That squares something. Then minus 4 parentheses 7, close parentheses, minus 3. Calculator does the whole thing for you. J of 7 is equal to 67. So if your input is numerical, you can easily just use your graphing calculator. But if we look at E, the input's not numerical. The input is a variable. So when I plug this in, I will plug it into H. So 12 is my numerator, right? We're looking here. And in place of X, I put an A. That's all I can do. I can't simplify that anymore. So H of A is equal to 12 over A. Let's take a look at F, because now I want to use function G. And with function G, I want to plug in this whole thing, this B plus C. b plus c goes in place of x. I am going to use my parentheses. I will write down -3, but in place of x, I'll put a b plus c and then plus 1. Um, let's simplify this a bit. Let's distribute. I get -3b minus 3c plus 1. Still nothing else I can do. I'm done. So sometimes when you substitute in a variable, there's not much you can do to it. Remember not to be tricked by things like letter H, I, and J. They're giving me the output here. That's an output. Okay, they're telling me the output of G is 16. I need to find X. I need to find the input. I just forget what G is. So I want to figure out what X gives me an output of 16. I'm just going to solve this. I could use my graphing calculator if I wanted to, but sometimes I think it's quicker for me to do it by hand, as long as I don't make my silly mistakes. If I divide both sides by a -3, I'm going to get x is -5. I can confirm by plugging in a -5 up here. -3 times -5 is a +15. Add on 1 is a 16. I could also confirm by using my graphing calculator. Let's just do another one. H of x. So the output is -2. I'm trying to find the input. Now, some of you still mess up things with these fractions to get rid of that denominator of x. I know I'm trying to solve for x, but I sure don't want it to be in the denominator. I like to multiply both sides by the denominator. I'm going to multiply both sides by x, and it gets the x out of the denominator. So now I have a -2x equals 12. That's much easier to solve. I could divide both sides by a -2. So x is -6. Let's practice using our calculator one time on this. So function h is, I forget it again, is 12 over x. So go to your y equals. Let's clear out what we have. Let's put in a 12 over x. I'm going to do alpha y equals enter to get a 12 over x. And I'll go to my table, which is second graph. And I'm going to scroll through until I find a -2 in my output. This way is positive. Notice that one error. Do you know why it's an error? I hope you said because you can't divide by 0, it's undefined. Anyway, if we scroll up to try and find a -2 output, not the input, the output, it's right here. When x is -6, the output's -2. So I'm happy with my answer when x is -6. Is there anything else we should practice? I think maybe something like L. Notice how it says I have to do -5 times f of 3. So -5 is going to be multiplied by whatever the answer of f of 3 is. So I'm first going to go do f of 3. Function f is x squared plus 7. And in place of x, I'm going to put a 3. So f of 3 is all I'm doing right now. I will do 3 squared plus 7. 3 squared is 9. 9 plus 7 is 16. Now I have to multiply it by this 5 that they gave us. I want to do -5 times this answer of 16. And what's -5 times 16? Should be 80. -80, I mean. So when you have to multiply a function, do the function first and then multiply it. So it's like following the order of operations. Like if we did letter N, you want to do j of negative 7 first. Then you're going to multiply it by 4. Then you're going to subtract your negative 1. Subtract your 1, I mean. Okay, so j of negative 7 gets multiplied by 4, and then you subtract the 1. So I'm going to leave you to do this, and I'll answer questions when I see you. All right. Have a good day.